have some questions about orange symmetry and when do we have it and when do we not. So orange symmetry. Think about this is when a graph has orange symmetry, it's rotating about 180 from the origin. But let's think about this algebraically, okay? So I'm gonna get my drawing. So I know, oops, I know I have x-axis symmetry. If I pick an x value, like an x coordinate, and I found this on the graph. So if I pick an x coordinate and I find the same values, but now the y is negative, then it does have x-axis symmetry. So let's take a look at this graph. So if let's pick 4, 6, somewhere here, right? So I have 4, 6. If it has x-axis symmetry, I should also find the point 4, -6. Well, let's see that. 4, -6, right? Somewhere here. So it does find that. So it does have x-axis symmetry. Yay! Okay, now let's check for y-axis symmetry. So I'm thinking about my points as well. So if I pick an x, y, I should also find -x, y. Okay, so we picked the same point. We picked 4, 6. I should also find -4, 6. Okay, so I go to the negative side here, and then I go up. I also find that. So it does have y-axis symmetry. Okay, so then I'm going to look for the origin. Okay, so for the origin, okay, if I pick a point x, y, I should also find on the graph -x, -y. So I'm going to pick the same point. So I have 4, 6. This means that if it has origin symmetry, I should find -4, -6. Okay? So -4, -6, right here. So it does have orange symmetry. Okay? So what this means is a graph, okay, wait a minute. If a graph is symmetric about the x and y axis, then it's automatically symmetric about the origin. So when we go back here, the moment that we have a yes for an x and a yes for a y, we will get a yes for the origin. Now, let's look at this scenario. Okay, so given this graph, determine if it's symmetric with x, y, and the origin. Okay, so if I have x-axis symmetry, I need to pick an x, and I should find on the graph x, -y. So let's pick, let me say 5. What would that be? 5, 2? Somewhere 5, 2? A little bit 5, 2? Somewhere there? Okay. You agree? Let's try that. 5, 2. It's not good. It's not that. We cannot see it that much, but somewhere there. Okay. So that means I should also find 5, -2. Okay. So I go to 5, negative. Let me use a different color so you can see that happening. No, actually, I'll stick with orange. So if I'm a 5, right, and I'm going down right here to 2, is there any graph there? Am I touching anything? No, you're not touching the graph. So no, it does not have x-axis symmetry. Bye-bye. Okay, let's try. You know what? Maybe it does have y. Let's check for y. Okay. Oh, my thing is slow. What's up with that? Something's going on. My computer is really slow right now. Oh no. Okay, so I have y axis. Let me check y. Maybe it's y. Maybe it's y. Yeah. So I have x and a comma y. So if it has y-axis symmetry, I should find the point negative x, comma y. Okay, I'm going to pick the same point. So I have 5, comma 2. So I should find negative 5, comma 2. Let's try. Maybe that will find. Okay, so negative 5. I'm right here. Oh no. Look, I'm right here at 5. If I go up, there's no graph, nothing. I'm not touching anything. Oh no. This is also a no. No y-axis symmetry. No. Okay, well maybe it's origin. You know? Let's check it out. What color should I use? Let's use blue. No, blue no. Let's use green. Okay. So for the origin, okay, if I have the x, so I pick this x comma y, in the graph, I should also have negative x comma negative y. Okay, so I'm going to pick the same point, 5 comma 2. So that means I should have the point negative 5 comma negative 2. Okay, so I am at negative 5 right here. And I go down. Oh, I just lost it right there. I was going up. Oh my goodness, I wish you would have seen my face. I wish you would have seen my face. I was like, wait a minute, this is not working. But it's somewhere over here, right? It's somewhere over here. Look, the 2. Yay. Okay, so the whole idea of this part is, so when we have a graph or an equation, and we're asked to find symmetry, if it's symmetric with the x and the y, it will be symmetric with the origin, all right? However, this does not go backwards. So meaning, notice in this case, it was not symmetric with the x, and it was not symmetric with the y, but it is symmetric with the origin, all right? So in conclusion, if a graph is symmetric about the x-axis and the y-axis, then it's automatically symmetric about the origin. But the reverse is not true. Okay, a graph can be symmetric about the origin even if it's not symmetric about the x or the y-axis. Okay, so my suggestion is when you are working with this, you know, just take the moment to, where I have lost the, okay, take the moment to go through this process where you pick a point and you find if that point is there. Make that simple substitution. All right, hopefully that helps.